So the coefficient of friction is a measure of the amount of friction existing between two surfaces. So a low value of coefficient of friction indicates that the force required to sliding to occur is less than the force required when the coefficient of friction is high. So the maximum coefficient of friction actually get is the maximum is 1. So the closer you are to 1, the more the force you require to move an object, and the closer you are to 0, the lesser the force you require to move an object. Having said that, let us look at this block of ours lying on a horizontal plane, and we're saying that this block is being pulled by a force P in that direction. And according to Newton's third law, for every action there's an equal and opposite reaction. Therefore, the frictional force F is an equal and opposite reaction to the force P. Likewise, our object here has a mass m, and it will exert a force multiplied by the gravitational force mg acting downwards. And likewise, according to Newton's third law, for every action there's an equal and opposite reaction. So the reaction to the force mg is the reaction n. So according to experiments done, that for every force P required, for every reaction n, the force P increases. So that's to say, if you keep on changing the mass of the object being pulled against the frictional reaction, the force P increases, and we see a linear reaction here. And if we are to take the gradient of this curve, we will get our coefficient of reaction. So according to this experiment, anytime you divide P over N, you get a constant value. So should you increase the value of the mass being pulled here, that is, of course, the reaction N increases, but likewise you require a greater force to overcome the force of friction. So for every set of force against the action, you get a constant. Therefore, P over N is equals to a constant, and this constant we call it mu, from the Greek alphabet. Mu from the Greek alphabet, mu. Therefore, P is equals to mu N. But we know that P is equals to F because it's an equal and opposite reaction. This also means that then we can say that friction force is equals to mu N. Now mu, or the coefficient of friction, in this case a coefficient actually means a multiplier. So since we are talking about P and N here, which have the measured in newtons, therefore mu does not have any units. So let us look at an example here to try and apply the principles of coefficient of friction, while at the same time considering friction on a horizontal ground. So the question reads that a milling machine table and component have a mass of 160 kilos. The coefficient of friction between the table and saddle is 0.02. Determine the frictional resistance to motion. So what comes to your mind immediately is you try and imagine a mill, and a mill, of course, you imagine this is a mass that is weighing 160 kilos and it's lying on a milling table. And of course, to pull this table, we'll have to have a force P on that side and friction resistance will be acting backwards. Now this weight will act to the center and it will act downwards as mg. Remember, here we have only the mass. We are now looking for the weight, which would y multiply by the gravitational acceleration. And likewise, we'll have a normal reaction N acting upwards. So what are we given here? We've been given the mass as 160 kilos. We have coefficient of friction as 0.02, and we know that gravitational pull is 9.81 meters per second squared, and we're looking for friction resistance. And in this case, what is our N? Our N will be the weight, which will be equal to the weight, which will be equal to mg. This case is 160 multiplied by 9.81 seconds. So from the formula that we know that F, or frictional resistance, is equals to coefficient of friction multiplied by the normal force. Therefore, our F should be equal to 0.02 multiplied by our normal force, which is mass times gravitational acceleration. This should give us, this has no units, this one will become 2 newtons. So if you multiply this, you'll have, supposed to get something like 31.4 newtons. Let us look at this more complex problem of friction on a horizontal plane. So the question is that a casting weighs 500 newtons, is moved with a steady speed over a horizontal floor by a force of P of 100 newtons acting at 30 degrees to the horizontal as shown. Find the value of the coefficient of friction between the casting and the floor. So this problem is not any different from that other one, just that it introduces a force acting at an angle. So I have drawn the same image here, showing us that force F acts perpendicularly. Remember, it acts perpendicularly to the normal, so it has to act parallel, or force F acts parallel to the horizontal floor, or the floor where the object is sliding, right? Likewise, the force P, to be equal and opposite, you have to resolve the force P to be parallel as well. We cannot use force P as it is acting at an angle. We have to resolve force P to be acting parallel to the surface. And likewise, we have to resolve our force P to the horizontal and to the normal components, and to the vertical components. So this is remember, our force P, as is pulling on this object, tends to lift this object. So we have to factor in that there's a component of this force P that will reduce the weight of this object, because it will tend to lift this object upwards. So I have drawn here a triangle to try and represent these forces. So that's a right angle there. And using the trigonometric functions, so we can call these sides the opposite, the adjacent, and the hypotenuse. And remember from your high school days, you used to remember these acronyms as SOHCAHTOA. So to get our opposite here, we see we have the opposite and the hypotenuse. Therefore, we can use the sine rule and say that sine theta is equals to opposite over hypotenuse. Therefore, likewise, our h should be equal to, our O should be equal to h sine theta. There we have our opposite. And likewise, we can use the adjacent here, and to get the adjacent, we use the adjacent of hypotenuse, which is the cosine rule, and say that cos theta is equals to adjacent of hypotenuse. Therefore, our adjacent is equals to h cos theta. So coming here to resolve the vertical components, therefore our vertical component in this case, we say that O is equals to h sine theta. Therefore, the vertical component should be equals to, our hypotenuse, remember, is P, and we already know P as 100 newtons, so it should be 100 newtons sine 30 degrees. From here, you know, sine 30 degrees is should be 0.5, therefore we have 50 newtons. Likewise, the horizontal component should be h cos theta, which is equal to 100 cos 30 degrees, which cos 30 degrees is 0.866, so we can get this as 87 newtons. Now here we have we know the vertical component is acting that way, and we also know that we have a vertical component acting upwards of 50 newtons. So therefore, this shows us that even the mass is reducing. So we are looking for the force, or rather we are looking for the coefficient of friction. So from the formula, we know that F is equals to mu r. Therefore, mu is equals to F over r. Remember, in our case, our F is 87 newtons. So apologize, I'm confusing with something else. Mu n, sorry. And our n, in our case, which is equal and opposite to mg, or the mass, is equals to 500 minus 50 newtons. Therefore, mu is equals to 87 over 450, which will give us a coefficient of friction of 0.19, and it has no units.